Today we're going to explore buckling and crushing of columns using Euler's buckling equation. Crushing load is a failure mode in which a member in compression suddenly fractures or fails and becomes unstable, as represented by the picture you'll see here to the right. The one on the right is a normal column, the one on the left is one that has failed under crushing. Buckling load is a failure mode in which a member in compression suddenly deflects laterally and becomes unstable. Represented by the column here on the right, the one in the red is a normal column, and the one on the white is one that has failed under buckling.
So this action of buckling was described in an equation by a man named Euler. He said P critical, which is the buckling of a column, equals pi squared times E times I over L squared. The E in the middle of this equation stands for modulus of elasticity. The I stands for area moment of inertia, and the L is length of the column. Okay, so now after viewing the basic Euler equation, now comes viewing the equation with the combination of a K value, which is it stands for different numbers that vary with the connections. So different connections consist of pin to pin, fix to pin, fix to fix. This K value isn't any specific unit of measurement. It's just a number assigned with each connection. As you can see here in the top left of the numerator, the K value is before pi squared. Here is each K value for each connection illustrated by this simple chart. As you can see on the far left, pin to pin, the K value is 1, pin to fix is 0.7, and fix to fix is 0.5. Next variable in the equation that we'll analyze and discuss is the modulus of elasticity. Each material has a different value of elasticity. Wood here you can see is 1,595,000 pounds per square inch, and steel on the right is 29 million. Alright, so the last variable of Euler's equation we will discuss is the area moment of inertia. This is portrayed by I. So here you can see the circle moment of inertia is I equals pi times the radius to the 4th power over 4. And on the right, square is 1 over 12 times the width times height cube. Each moment of inertia for different shapes is different. So a square shape is more able to resist buckling than a circle because in the square center axis, more material is spread out away from the axis rather than a circle.
Here we have our chart filling out the Euler-Buckley equations for the different materials, lengths, and connections during this experiment. The areas in the middle represent the different variables for each equation, with the ultimate solution at the end, the PSI, that will induce buckling on the far right column. So for instance, on a 30-inch wood dowel for its pin-to-pin connection, it will need 16.97 pounds approximately to induce buckling. Here we have our testing apparatus. We have created a compression system that has 4 vertical members and a piece of plywood sliding up and down the members. This will allow us to place a sample column underneath the wood in between the 2 pieces and put weights on top. This will simulate the compression. We will use bricks and cinder blocks to create the weight required to induce buckling. Here we have a summary of our results. As you can see from the 3 right columns, we have the PSI using Euler's equation, the actual weight we found during testing, and the difference between the two. Several of the pieces, the wooden dowel 30-inch, the wooden dowel 36-inch, and the wooden 42-inch, all were pretty close. Some of the other ones, though, we found varying differences from what Euler's equation called for and what we actually found. This can most likely be attributed to the testing apparatus. While it worked very well for the experiment, there was some friction created by the plywood on the poles, which could reduce the amount of weight that it took or change what it took to buckle. From that point, that mostly justified the difference. But for the most part, this test showed that indeed the longer the column gets, the lower the buckling level is. Additionally, the different materials can affect the buckling weight and different shapes as well, where the square is more than the circle.